Rearorden. And here we go. Except that I'm not recording, or I mean, I don't have the thing up on the board here. So imperial mass in the metric system, you know how to solve for x, right? With that first thing, the very top. You better, right? Uh-oh. Okay, now it's good. To solve for that x, cross multiply 16 times 288. Divide by 1. That's expected to do in any section, workplace 10 or 20, pretty much it comes up. When we do that, you got your calculator handy? You got an answer already? For the first, let's get a rolling. Pardon? Okay, remember that to solve any x in a proportion. This one here. You cross multiply, you look at where the x is, and then you do the diagonal numbers. 288 times the 16, and then you divide by the lower. So you always do it that way. Cross multiply, divide by the lower. Make sure you're, and I'm talking as if other people are watching the video, Janelle. Make sure that you can always solve that kind of equation. In this case, Janelle, you got it, right? Huge number? 4,608. And we're going to use that skill all through. Let's read carefully though. The mass of an object refers to the quantity of matter in it. You've heard of that in science. And it remains constant, no matter where the object is located. The weight of an object is a measure of the force of gravity on the object. On Earth, the mass and weight are about the same. But other planets, they might not be the same. The moon, things were way less but still have the same mass, for example. Enough about outer space. Here, though, put a circle around these, because these are important. 1 ton is 2,000 pounds. This is old school system, like imperial system, not the metric. And 1 pound is 16 ounces. Those are important. So highlighting that, we'll be using it. Example. Manuela needs 1 pound and 2 ounces of Gruyere cheese, 12 ounces of cheddar cheese, 11 ounces of Swiss cheese for a fondue recipe. How much cheese does she need in all? Pounds and ounces. You got to sort it like you're adding up time. Now, just as an aside, Janelle, before we do this, let's think about time where you would know how to do things. If you were adding up, sort of like adding time where you have hours and minutes, if I said you had, and I'll do this as an aside over here with time, it's the same skill. If you said you had 1 hour and 45 minutes, and then someone says, well, stay an extra half an hour. So you said, okay, that's another 30 minutes. You can do this in your head, but arithmetic-wise, you'd say that's 1 hour and 75 minutes. And then once you see that, you realize that 60 minutes is a full hour, right? So then you got to regroup it. You got to subtract the 60 off of it. And you'd say, well, this is 2 hours, 75 minus 60, 15 minutes. Or you probably go like this, 2:15, like that, right? Well, the reason why I did this is sort of like working with pounds and ounces. 1 pound, 2 ounces. Every time you hit 16 ounces, you've got an extra pound. So, this problem asks you how much cheese, poundage-wise. Now, luckily in our stores, they advertise both pounds and the grams. But luckily, we buy things in grams, because pounds and ounces, They're not fun to work with. Well, let's add them all up. We got to set it up like I did with that time thing. I'm going to put 1 and an LB per pound, 2 ounces. So that's this one. Of the air cheese. 12 ounces of the cheddar. So you see where I get 12 ounces of cheddar plus the 11 ounces of the Swiss. Add that on. Sort of like 2 mini problems to add, and then you regroup. 2 plus 12 is 14, plus another 11 is 15, 25. You can use a calculator. However, I'll wait for a second. This is 1 pound, 25 ounces. You know that 16 ounces makes a full pound, so you think, I could take one group of 16 out of that 25, right? So in your head, you're thinking, I'll just do this up here. And I'm thinking, okay, I'll take out a 16, minus 16, doing this so I can add 2 pounds. 25 minus the 16 is your 9 ounces. I'm going to excuse myself for a second here. Hello, Joel Sandaka. I'm sorry? It's... Oh, okay. Wow. Yeah. Yes. Okay. Okay. Yes, I am. Okay. Okay, sounds great. You betcha. Okay, bye. Just got to write that down. Okay. So does that kind of make sense, that one? It's not too bad. 2 pounds, 9 ounces. Sorry, got that in. Now let's try this. When you do this later, your turn. Kermit and Trina are proud parents of 2 twin boys. Their newborn weights are 6 pounds, 8 ounces. 5 pounds, 13 ounces. You're going to add those up when you get after the lesson, and then find out what the total weight of the 2 boys is. If you had them both in your arms, how much in pounds and ounces again. And you'll have to regroup on that one, okay? It's the same kind of problem, just add it. Let's just see about this. Tons now. The cab of Arthur's semi-truck weighs 8.7 tons and the trailer weighs 6.4. If the loaded gross weight is 21.3 tons, what is the weight of the load? Now, do you understand the problem, kind of? The whole truck, you know, the front of the truck, that's what we're talking about. The semi-trailer truck weighs 8.7 tons. He's pulling a trailer at 6.4. The trailer plus the truck plus whatever's on the load add up to 21.3. Okay? So, or what is that? How is it given? If the loaded gross weight of the truck is 21.3, what is the weight of the load? And then in pounds, in tons and pounds. So everything added together is 21.3, right? So 21.3 tons. Now, as far as abbreviations, we will use TN for tons, and that's from here. Okay. And the cab of his truck weighs 8.7, so we got to take that off. We've got to take off the weight of the trailer. Then we can find out what they actually loaded onto it. Right? So using a calculator. Do-do-do. 21.3, 8.7. Let's see if you and I get the same numbers. You'll tell me in a second here. And you get 6.2? 4. Okay, I'll just check in a second here. So we got 21.3 minus 8.7 minus 6.4, and I get 6.2. Did you try that again? Yeah? Okay. No problem with the entry error. Now, how do we get that into pounds? You got 6.2 tons. We got to go back to what we circled here. 1 ton is 2,000 pounds. I'll remember that when I put the image. And I'm going to put that as a fraction. 1 ton, 2,000 pounds. Put it as a fraction, and then you got a fraction on the other side. Make sure you label LB for pounds, TN for tons, because then you'll know where your X is. We want to convert 6.2 tons. And I put it on the top so that the TN tons are matching. Tons there, tons there. And then we solve. So this is where you cross multiply 6.2 times the 2,000, divide by the 1. We'll double check together. $12,400. Great. And make sure you have a unit on there. That's the load of the truck. 12,400 pounds is the weight of the load. When there's word problems, make sure you have units and some words to describe what you found. Okay? Now after that, the next problem there, I'll get you started on it. An elevator has a maximum load restriction of 1.5 tons. Is it safe for 2 tile layers weighing 195, 210 pounds to load it with 65 boxes weighing 42 pounds each? That could be a real concern. Well, since everything, all these little numbers are in pounds, let's change this 1.5 tons to pounds first, the restriction. Okay? I'm going to label it over here as the restriction. We'll find out what that is in pounds. So, for tons, remember that it's 1 ton for 2,000 pounds. We want to know what 1.5 tons is. So tell me what you get. 3,000. X is 3,000 pounds. That's the max on the element. 3,000 pounds max on element. It's not safe after that. And we'll just draw a little separation. We're going to figure out how much they actually are trying to load on there. Let's do this first. There's 65 boxes weighing 42 pounds. So we're going to add up 65 boxes at 42 pounds. We'll multiply it. 42 pounds times 65. And that I'll give you. It's 2,730. You use your calculator, and you would add that to the weight of the two guys. The two guys weigh 195, 210. You add that up. I'll just do it without a calculator. 5, 10, 13, carry the 1, 8, 9, 10, 11. Carry the 1. Uh-oh, they're over. So that's 3,135 pounds. That's not safe. So your turn. Is it safe? Not safe. They could do this though, because it's only 135 pounds over. They could just send one person up, right? At a time, or else cut the load in half and just send it in 2 trips. Now, what you're going to do is these conversions from the first page, 12 ounces to pounds, pounds to tons, ounces to both, you know, like 3 pounds, 4 ounces or whatever, that's definitely not the answer. And vice versa, just strictly to ounces. So you'd multiply this by the 16 and just add it to ounces. 4.5 tons is how many pounds, ounces to pounds. Those ounces and pound mixtures are kind of tricky. And then some more assignment questions there, word problems, okay? Good luck on it. I'll stop the recording for you. Meeting. Stop.